In this video, we're just going to play with series a little bit more. You see f of x is approximated by that series. Find f of 2, f prime of 2, and so on. So, of course, we're going to require, you got to have this down pat, this way of finding a series. Like that. It looks, of course, like in our example, a is equal to 2. Right? Because that's what's in here. So we're all good there. So let's start right at the beginning, f of 2. So this is the zeroth derivative. Remember, the zeroth derivative is the function. So what I know, using the formula at the bottom, is that the zeroth derivative at 2 over 0 factorial is equal to the coefficient that goes with x to the 0. Well, in our case, that's 3. Now, I multiply both sides by 0 factorial. Of course, 0 factorial is 1, so f of 2 is just 3. Okay. Next, let's go to f prime of 2. F prime, so the first derivative over 1 factorial, and that goes again with the coefficient of x to the first, or in this case, x minus 2 to the first, so that's equal to 5. Multiply both sides by 1 factorial, so this is 5. Okay. The second derivative at 2 over 2 factorial is equal to, so this is the coefficient that goes with x squared. So be careful here, it's negative 4, so bringing that down, negative 4 like that, multiply both sides by 2 factorial, and we get negative 8. And finally, f triple prime, so f triple prime at 2 over 3 factorial. Always remember it's the same. Third derivative, 3 factorial. And the coefficient that goes with that is positive 9. Multiply both sides by 3 factorial, so 9 times 6 is 54. And there I've solved for all of those derivatives. All right, let f be the function defined by that. Find all values for which the series, okay, so find the interval of convergence. That's part A. Okay, so the interval of convergence, remember we always set up a ratio test. So do that here. Let's do some simplifying. 2 divided by 2 is out. Remember that leaves us with just an x plus 2 over 3, which I would pull out front and have x plus 2 over 3 times the limit as n approaches infinity. Now we've pulled everything out, so all that's left in there is 1. And remember, ratio test, we're just trying to have this be less than 1. So what we're really solving then, because this is just 1, we're really solving that x plus 2 over 3 has to be between negative 1 and 1. We've got to account for that alternating piece. So multiplying both sides by 3, and then subtracting 2, we get that. Now, we should go back and just plug in those endpoints, right? If I plug in 1, I get 1 plus 2, so I get 3 over 3. Maybe I could write that down. I'll write it right below it. If I plug in 1, I get 2 times 1 to the nth. Well, that obviously diverges. Okay, because it's just 2 plus 2 plus 2. If I plug in negative 5, I get 2 times negative 5 plus 2 is negative 3, so I get negative 1 to the nth. So now it just alternates between 2 and negative 2. That also diverges. So this is your interval of convergence. Solving the bottom piece, it says find the function. Well, when it says find the function, you really have one of two options. It's either a series we know, like a Maclaurin series of e to the x, or sine of x or cosine, or it's some, simple substitution or simplification of that, or it's geometric. Well, this is geometric. It's a function raised to the nth power. So I'm going to treat this thing as a geometric, and remember that the sum of a geometric, if I added up all the terms, I get a sum. Well, adding up all these terms would tell me what the function is. So I've got the first over 1 minus the ratio. So for us, if I plug in, you'll notice it starts at 0. If I plug in 0 for n, 2 times anything to the 0, so the first term is just 2. And 1 minus the ratio is what's being raised to the nth power. So that's x plus 2 over 3. So if I got a common denominator, dividing by a fraction, same as multiplying by a reciprocal, so this becomes 6 over 3 minus x minus 2, which would be 6 over 1 minus x. And this is the function that when you add up all these terms, the series will keep getting closer and closer to. So when it says find a function, as I said, you're either looking for some kind of manipulation of a series you've already worked with, like e or sine or cosine, or you're looking for something that's geometric that you could use the sum formula to figure out what, if you kept adding terms over and over again, what this would get closer and closer to.